These are called CFLs, context-free languages. Right? Remember, these are ones for which you can make a grammar where the thing on the left side is always just a single non-terminal. So something like S goes to AS or BT, T goes to AT or epsilon. All right, this is a that's called a context-free grammar. And the language that it generates is a context-free language. And context-free means the left side of the arrows is always just a single non-terminal. No other funny business on the left side. You can put whatever you want on the right side, but the left side is just a single non-terminal. That is a single big letter. All right? This is context-free. Can anybody look at that, by the way, and say what's the language generated by this grammar? The language for that one, just as a sidebar, curiosity. Yeah.
It's just ABA anything. That's something that could be accepted.
AB, yeah, certainly you can make ABA, but actually you could, for instance, getting the first A, you could go through this projection several times, so you could make a little more. What do you? Any string with only A's and one B. Yes. Actually, I think that's right. I was going to write that in a different way. Anybody have a different way of saying that? Yeah?
A to the M, B, A to the M.
Yeah. A to the N, B, A to the M. Something like that. Right? This is the same as saying it's all A's except it has one B. Yeah, basically when I see this, I say, oh, well, I could do this one over and over again to make a bunch of A's on the front. At some point, I have to do S goes to BT, which makes one B. And then the T can make a bunch more A's. T goes to TA. And then you stop eventually with epsilon. So yeah, that's what the language is of that grammar. Yes?
Could an N be the same at some point too?
Yeah, they might be equal. Either of them might be 0, but they don't have to be equal. But yeah, there are no required relationship. So that one is context-free. Something like S goes to AS or BT, and then ABT goes to AB, T goes to epsilon. How about that? ABT goes to ABS. Yeah, this one is not a context-free grammar because of that middle one. And to me, at least, non-context-free grammars are much harder to make sense of. You have to consider a lot more closely. This one may not be so hard to make sense of. I'm not sure. Anyway, this is not a context-free grammar. To tell you the truth, it may be that I'm bad at doing them just because we are not really going to talk that much about non-context-free grammars. They're much harder to analyze. We're going to focus a lot on context-free grammars. All right? This one is not context-free. The reason is because of this weird thing on the left-hand side. Context-free means no funny business on the left side. All right? As we've seen last time, you can always convert a regular language to a grammar. So remember, last time, any regular language, regular, has a grammar. And we talked about how exactly you can convert an NFA into a grammar. This, in my opinion, last time's class was slightly boring. I don't know if you felt the same way, but there's a lot of fairly easy, but you just got to do it kind of stuff. To me, that's kind of boring if it's sort of simple, but you just have to learn how to do it. Anyway, any regular language has a grammar, and we talked about how you could convert an NFA into a grammar. And the grammar that you get is what we call single-step grammar. They are very simple format. So I'm going to say any regular language has a grammar, and these grammars are always context-free, right? CFG, when I say CFG, that means context-free grammar. Context-free grammar. A context-free grammar generates a context-free language, all right? Any regular language has a grammar, and those grammars are always context-free grammars because they are single step, which is very simple format. And so, I guess you could write this as a theorem. I'll write it as a theorem. Any regular language is a context-free language. Right? Any regular language is automatically context-free because you can make a single-step grammar for a regular language, and those grammars are context-free grammars. All right? So any regular language is a context-free. The converse is not true. There are some context-free languages which are not regular, but some context-free language are not regular. Anybody remember? We actually have talked about examples of that. Yep. Yeah, you remember? Yeah. Yeah, right. So some context-free language are not regular. The standard example is A to the n, B to the n. Remember the grammar for this one is S goes to A, S, B, or epsilon. Right? That is a grammar. And that grammar is context-free because the thing on the left-hand side is just a single non-terminal symbol. All right? So actually there is what they call a hierarchy. Is this how you spell it? Or is it EI? I think it's that. Hierarchy of languages. From like they're very simple ones, and then this sort of increasing complexity of languages that we're going to be talking about often for the rest of the semester. So far, we focus on regular languages, but those are like the very simplest kind, and there are increasingly more complicated kinds. But for now, I will just say there's the regular languages, which are like their own little thing, but then these live inside a larger universe of context-free languages. And in fact, as we go on, we're going to talk about larger and larger kind of types of languages. But there are regular languages, and there are things which are not regular, but they still count as context-free. And actually, we can say, like, the typical example of a regular language, I would say, is like A to the N, that's regular, right? And whereas something that's context-free but not regular is A to the N, B to the N, right? That one is not regular, but it is context-free. That's why I put it like with a little dot. Yeah?
So everything outside of regular is just not regular?
Yeah, when I say not regular, it means not regular. So some of those things are context-free, but actually there are things out here also. I will just say, for now. We will talk about examples eventually. And they're not even super complicated. And there are also larger and larger sort of circles that I'm going to draw on this diagram. All right, this is sometimes referred to as the Chomsky hierarchy. Chomsky hierarchy. Chomsky is the name of a famous linguist and computer scientist, and now sort of political, cultural rabble-rouser named Noam Chomsky. Noam. I don't know if you've heard of him. He's very old now, but I occasionally see him on Twitter or whatever, giving his hot takes about geopolitics. He's very, I think he describes himself as an anarchist. And he's fairly outspoken, and there are a lot of, I suppose, anarchist types who really love Chomsky, and they think that we need to rebuild the structure in the way that Chomsky says. I don't actually know much about Chomsky or anarchism. I know something about Chomsky. Chomsky actually is the originator of grammars. He was the one who came up with the whole concept of using grammars to analyze. He's a computer scientist and also a linguist, like of natural spoken languages, and so he came up with this kind of computational approach to linguistics. So super important work that he did. Anyway, this is the Chomsky hierarchy of languages. The regular languages are the most simple ones. Then there's the context-free, and there are other ones that we'll talk about eventually. All right? What I want to focus on mostly today is, if I describe to you a language, can you make me a context-free grammar for it? So, making a context-free grammar for some language. All right, that's what I want to focus on today. I give you a language, can you make me a grammar for it? And we're going to talk about some different sort of simple tricks and strategies for doing this. So the first and easiest, because we've already talked about how to do this, is regular languages. If what I described to you is actually a regular language, then those are always easy to make a context-free by converting from an NFA. Or easy, I mean, sometimes making an NFA is not easy, but at least we know how to do it. So regular languages, I would suggest make a NFA and then convert to a grammar in the way that we talked about last time. This is always easy to do. At least the conversion part is always easy to do. Hopefully, if it's a regular language, you'll be able to make an NFA for it. All right, so we don't really need to talk much more about that, because that's what we did last time. I would like to talk about another main focus or feature of actually almost all of the non-regular languages that we've seen so far. The reason that they're non-regular is because of some kind of repeated part of the string, like a to the n, b to the n. It's because that n, because you make that n be the same both times, that's what makes it non-regular. I'm going to refer to that sort of situation as balancing. This, I mean, something like a to the n, b to the n, but it doesn't have to be exactly that. It could be more complicated types of balancing, or even that one that was on the quiz today, a to the n, b, a to the n, b, right? This also has part of it which is balanced with some other part, all right? Now, let's just focus on this one first. Why I call this balancing? It's because each A is balanced with a B. All right? Each A is balanced with one B. And the strategy for doing this is create them at the same time from the middle. And because we've already done this example so many times, you will understand what I mean by from the middle, like this. All right? What I mean by create them at the same time is whenever you generate a new A, you should generate a new B at the same time. This will make sure that the number of A's is always balanced with the number of B's. There is no step which makes an A without also simultaneously making a B. This is how we ensure the number of A's is the same as the number of B's. And then I also said from the middle. The reason you have to do it from the middle is, well, just because that's how this works. So this one will work. I will say it doesn't work if you did something like A, B, S, or epsilon, all right? This one still has some kind of balancing. The number of A's will always equal the number of B's in this case, just because every A is matched with a B. But because you put the S on the end there, can you say what kinds of strings will be generated here? This one, it doesn't generate a to the n, b to the n. Generates.
It's like A, B, A, B.
Yeah, a, b, a, b, a, b. Actually, you could write it, if you insist on using an n, it would be that, a, b to the n. But actually, this is considerably less interesting as a language, because that actually is a regular language, right? There's only one n in there, so it's regular. All right, anyway, this is the strategy for balancing. So, for example, can we try them? How about, let's try a to the n, b to the 2n. All right? I want to think of this in terms of balancing also. And the way that I think of this is each a balances with bb, right? Every a this time matches with two b's. So, with that as your inspiration, can you perhaps, inspired by a to the n, b to the n, how would I write the grammar for this? What do you think? Yeah, that's it. Or epsilon. ASBB or epsilon. Yeah, each A balances with BB. Excellent. How about just some more simple variations? A to the n, B to the n plus 1. If I were to think this through, I would say each A balances. You know, once you get good at this, you're not going to have to write these words, but I'm trying to explain my thought process here. Each A balances with B, but there's one extra B. That's all. All right? There's an extra B. What do you think?
ASB or A or B.
Yeah, ASB or B. So just at the end, rather than stopping with an epsilon at the end, I stop with a B at the end, which ensures that there's going to be one extra B. Excellent. All right. How about, this one's a little slightly fancier. Oops. How about this? A to the n, b to the m, where m is greater than n. So if I were to describe this one in similar terms, I would say something like HA balances with B. But there are several extra B's, one or more extra B's, right? But one or more extra B's. That's how I would describe that. What you got?
S to B, the S to ASB or BT,
Uh-huh.
and then T to BT or epsilon.
Excellent. Yeah, I like that. So S goes to ASB. This you do over and over again, and you will end up with exactly the same number of A's and B's. And then, after you do that for a while, you switch over to this one, which gets you a B, at least one B. And then you can make more B's if you want to, down here. And this will produce extra B's in the middle. And then you stop by going to epsilon. Yeah?
Oh, actually, never mind.
So you might have, this is equivalent. I mean, that's a perfectly fine answer. You could also do it this way. S goes to ASB. Oops. Or T. T goes to BT or B, like that. You have to make sure that there is at least one B, but this will do it also. I don't know why I kind of like the second one better, but no offense. This is perfectly great too. How about, just because we just saw it, how about the one on the quiz? A to the N, B, A to the N, B. Think about what exactly is balanced with what else. Let's see if we can fill in. Actually, this one is a little weird. The B on the end is a little weird. Can we do it without the B on the end? That's a lot easier. And then the B on the end is actually something else we're going to talk about. How would you do this one? A to the N, B, A to the N? Yeah.
It's S to ASA
Uh-huh.
or T.
Or T?
Or B.
Or B, yeah. You don't even need a T in this one. S goes to ASA or B. Yeah. Doing S goes to ASA gets you those A's on the two ends, an equal number of them, and then you stop by putting a B in the middle. Great. All right. Any thoughts about that? This is sort of simple tricks involving balancing. What about some more simple tricks? How about involving concatenations? And then this actually will help. How exactly would you make sure there's a B at the very end of this string? That's a little tricky, but once you understand about concatenations, actually there's a very simple trick which lets you get concatenations. For example, how about something like a to the n, b to the n x, such that x has let's do this. How x has an even number of b's. All right. It's a little weird, but just because of the way it's written, this one is convenient to think about in terms of a concatenation, right? It has two parts, and hopefully I can handle those two parts separately. Certainly the first part I can handle as a simple balancing like we just did. So this part is S goes to A, S, B, or epsilon, right? That's the first part. What about the other part, X, such that X has an even number of B's? That's a little strange, but actually that is a regular language, isn't it? This even odd stuff you can do with the DFA with two states, right? So that second part, I'm going to think this is regular, and so if I had to make a grammar for it, I mean you could try to just write a grammar sort of from scratch, but you can always write a DFA. It would look like this. This is a nice little review from last time. Even number of B's. So this sort of back and forth thing where this is accepting and B's take you back and forth and A's don't really do anything. All right. This is a DFA for something which accepts a string with an even number of B's. And then to convert to a grammar, I would give them names. So I'll call this S and this one T. And then as a grammar, it'll say S goes to BT. I hope you remember the procedure for this. Each arrow on the NFA turns into a production. The arrow S goes to T with a B arrow translates into S goes to BT. And then S goes back to itself with the A arrow translates to S goes to AS. And S is an accepting state. You put or empty string. And then it's going to be T goes to AT or BS. And not or epsilon. I think I did that right. All right. So this is a concatenation. I have grammars for each of those two things. And there's a very simple trick that you can use to concatenate two grammars. Here's how you do it. To concatenate. Can concatenate. You got to start with S, but here's what we do. S goes to S1, S2. And then S1 is that first one. A, S1, B, or epsilon. S2 is that whole grammar from the second one. So what I'm doing is I'm taking this and turning that into S1. That's the grammar for, the S1 is here. So that's the grammar for like the first part of the string. And then the second part of the string is S2, and that I'm going to plug this entire grammar in down here. I have to change the S's to S1 and S2. But this becomes BT or AS2 or epsilon, and then T goes to AT or BS2. All right, so this one gets plugged in right here. And this will always work. If you have two grammars and you want to concatenate them together, that's how you do it. You make your starting state, just go to two separate starting states, and then make those the two starting states from your two grammars you're trying to concatenate. All right? This is how we would do concatenation. So maybe we can just try that one that was on the quiz, which I said, this is a very, very simple type of concatenation, but A to the n B, A to the n B, all right? I think of it in terms like this. I'm concatenating A to the n B, A to the n, because I already know how to do that. That one was S goes to A, S, A, or B, right? Yeah?
How do you know where to draw the?
Yeah, this is actually an important question, and there's no simple answer. I chose to group it like this. Why did I choose to group it like this? Basically because I've been doing this for a while, and I know where to do it. It's not obvious, but in this particular example, actually any other way that you might try to group this is not allowed. For instance, you cannot group it like that because this n has to be equal to this n, and so it doesn't make sense to separate those into two separate groups, because these n's, wherever they go, they better stay in the same group, no matter how you're going to break it up. Given that, then this is the only way that you could break it up. You have to keep the n's in the same grouping.
So
Yeah.
isn't that kind of something we should look for, is like if there are ends kind of grouped together, that's maybe a good place to break it up, or?
Well, yeah. I mean, I would say you absolutely cannot separate the ends. And yeah, I suppose those would be a good place to break it up. Yeah. I mean, if you have something like a to the n, b to the n, a to the m, b to the m, then this one you would break up like this, right? And it would not make sense to break it up any other way.
So then
Yeah.
what if like the last one was a b to the n, would you just not be able to break it up?
Now you got problems. Yeah, if it's b to the n on the end, then you start wondering if this is even possible to do with a context-free grammar. I'm pretty sure that's not possible to do with a context-free. Or maybe it. I mean, maybe you can work it out somehow, but I happen to know that one's not possible. So, yeah.
A to the n.
If you have n, n, m, n, I think that you can't do that with a context-free. You definitely cannot try to handle this as a concatenation, because the n at the end has to match up with the n on the beginning. Anyway, can we just finish this one over here? We know how to generate the first part with a grammar. How do we generate the second part with a grammar? This is like almost stupidly simple. Can you give me a grammar which just gives you b? Yes, S goes to B. Okay, great. So that means my final answer is, when I concatenate those two things, S goes to S1, S2. S1 goes to A, S1, A, or B. S2 goes to B. All right? And as usual on these kind of constructions, you might wonder, could I simplify that? And in this example, you can simplify it. There's actually no reason to have S2 as its own thing, because S2 can only become a B. This is actually the same as. But as usual, I don't really care if you simplify it, but this is the same. All right. Concatenation really works. We got 10 more minutes. That's enough to give you one more simple trick, and then we'll try some examples. I had a bunch of examples for you all to try, but we'll probably wait.
Wouldn't the second one not work because you need a B at the end, and that would just put the B in the middle for A to the N, B to the.
I think this is okay. This B definitely goes on the very end.
Oh, I didn't see that. Yeah, I thought you kept S1, S2.
Yeah. I just changed it because in this one, S2 has to become B, so you might as well just put the B right there. Yeah. Yeah, this B here ends up in the middle. That's true. All right, great. One more simple trick, and then we'll do some more examples. How about unions? Concatenations are easy to do with this kind of strategy, this sort of S1 and S2 thing. Actually, there's a very simple trick for doing unions too. It's almost the same as this. When I begin with S goes to S1, S2, it means we have to start with something from the first grammar followed immediately by the second grammar. For unions, really this is about like the logical connection or, right? I want to start with something from the first grammar or something from the second grammar. Does that inspire anybody to say what the strategy should be? Yeah, so basically you do it like S goes to S1 or S2. And then you say S1 goes to whatever, S2 goes to whatever, right? So if you want a union, you figure out your two grammars for the two things which you are unioning, and then you union them, all right? So for example, something like, well, how about this example again? A to the n, b to the n. As a concatenation, we did a to the n, b to the n followed by x, where x has an even number of b's. Let's try instead a to the n, b to the n union x, such that x has an even number of b's. All right? So this is just any string, so this language, L, has any string that looks like a to the n, b to the n, or has an even number of b's. And that we can make a grammar out of by combining with the union. And it's, we do the first two grammars first, but then I just connect them like that, S1 or S2. And then S1, we worked this out before, is A, S1, B, or epsilon, and S2, even number of b's. It was all that stuff that we wrote before. Would you mind if I just copy and paste it? It's this stuff. I know it's hard for you to copy and paste on your paper. I took too much in my copying. I don't know what to do now. Let's erase that. There we go. All right. You use the bar here. That's the thing, to get a union. Very simple tricks. All right, how about let's just do a couple examples and that'll do us. Let's try a to the n, b to the m, such that m is greater than n. This one we already did, just in terms of, we said this is balancing where the a's balance with the b's, but there's extra b's at the end. But actually this you can also think of as a concatenation. So the moral of the story for this example at least is sometimes it's not written like a concatenation that makes any sense, but you can rewrite it in a way which is helpful as a concatenation. Now, I mean, this actually, as written, it does kind of look like a concatenation, but you cannot split it apart because there's a relationship between the n and the m here. The m has to be bigger than the n. But I can do this. This is a cute little way of rewriting the same thing, but turning it into a format which I can analyze as a concatenation. All right? I hope you agree these are the same. This says a to the n followed by b to the m, where there's extra b's. And this way around of writing it is just, here I wrote the same number of a's and b's, and then there's some more b's. So they are the same language, but this second one is more easy to represent as a concatenation. And then, how do I do the grammar for that then? Well, it's a concatenation, so I'm going to go goes to S1, S2, and then S1 is the first part. That would be A, S1, B, or epsilon. That's the same old balancing, very simple balancing. And then the second part is just a whole bunch of B's. So that you can say B, S2, or B. There has to be at least one B in the second part, and so I did a ending off with B rather than ending off with epsilon. All right. So sometimes it doesn't look like a concatenation, but you can rewrite it as a concatenation, and it works out great. I got one last example, and then we can break out the pina coladas, whatever. I get my trunks. How about this? A to the n, b to the m, where n is not equal to m. This is another one where it's not obvious, but we're going to rewrite it in a way which makes it obvious to do as either a concatenation or a union. You might try to do this as a concatenation, but the problem here is you don't know which is bigger, the n or the m. If the m was bigger, then actually it would be the same as the one we just did. If the n was bigger, you'd do it the other way around. But since we don't know, that's where the problem is. Actually, we can do a union for this one, which will make it possible. And the union may be suggested by what I just said. We don't know if the n is smaller or if the m is smaller, right? But actually, it's got to be one or the other. So I'm going to write this as a union, a to the n, b to the m, such that n is less than m. Union, a to the n, b to the m, such that m is less than n, right? Those are the two options. If n and m are not equal, then either, one is smaller or the other one is smaller. And then each of those we know how to make a grammar for, right? And then we combine them doing the union. You think we can just sort of do it all at once? I'm doing a union, so I go S1 or S2. And then the S1 is going to be for the first set, right? The first set is what the S1 refers to. Can anyone give me a grammar for the first set there? This is fewer A's, right? Extra B's. That's actually the same one we just did, right? So I'll just copy that. Now that itself has several parts, but I'll say S1 goes to, maybe I'll use it, rather than more S1s and S2s, how about, this has extra B's. So I will say A S1 B or T, and then T goes to B, T, or B, right? You do this one over and over, which makes an equal amount, and then you shift over to T, which just makes a bunch of extra B's. And then, how about the other one? S2. Someone want to tell me how to do this one? It's very similar. Not exactly the same. Except for the B's. Yeah, the extra B's should be extra A's instead, right? So I will go A, S2, B, or how about R? And then R creates extra A's. R goes to AR or A. I think that'll do it.